Alright, I'd like to go through and do just a few Hess's law problems with you. Let me show you how they work and some of the basic ideas here. The first thing you need to realize is that when you add reactions, whatever you do to the reaction itself, you're going to do to the enthalpy change as well over here. So if I flip the reaction, I'm simply going to change the sign. If I need to double it, of course I would double this. If I need to cut it in half, I'd cut this in half and so forth. The other thing you need to recognize is that you can kind of look at all of the reactants. Things on the left side is coming down together and things on the right side is coming down together. And as you do this, if you have the same thing on the same side, they will add. So if I had like some H2s here and some H2s here, I would simply add them together. If I have them on opposite sides, they actually cancel. So notice I have an H2 here and an H2 here. They would cancel as well. By the way, recognize the font I'm using did not do the subscript, so that is a subscript 2 and a subscript 2. So the first thing I tell folks to do when they're doing these is try to get the correct things on the correct side. So we need to first of all look at where we are going. What is our final equation? And where do we want the various chemicals and formulas, I guess I should say, as you look at these things. So let's start by looking at HF. Right now, HF, if I add all this up, will come down on the left side of my arrows. If you look at this final equation, though, I don't want it on the left side of the arrows. I want it to come down on the product side. So what that lets me know is I'm going to need to flip this equation. So I'm going to write this as H2 plus F2, and that's going to produce 2HF. And when you do that, you change the sign. So this sign is no longer positive 542, it's now negative 542.2. So with this first equation, again, I knew I needed to flip that because I needed this to come down on the right side. Now as you do this, always be careful that you don't have it somewhere else. Perhaps another equation is going to put that down on the right side, but in this case, this is the only place there is any HF. And so I'm going to scribble that one out because I've now flipped it and turned it into this equation. Now let's look at my second one. Do I need to flip this one? Well, if you'll notice, I've got kind of the same issue here. I need this H2O to come down on the left side of the arrows. Right now this is coming down on the right side of my arrows. See how it's a product? So I'm going to have to flip this equation as well so that I can get the H2O to add on to the left side. So I'm going to rewrite this as 2H2O arrow 2H2 plus O2. And same thing, I'm going to have to flip the sign and make this positive 571.6. So again, now I have flipped this second equation. And now, again, I have my correct things coming down on the correct side. So the second thing I tell folks to do is let's look at the coefficients. Do I have the right numbers of things? In my final equation, I actually want no h's, so I'm going to need those to cancel, and I have 2 here. So that leads me to think I'm going to need to double this. If you notice here, F2, I'm going to need 2 F2s, so really I'm probably going to have to double this, and then this finishes it here. I've got 2 HF. I want 4 HF at the end. So I'm going to have to double this whole equation. So I'm going to make this a 2, this a 2. This, of course, becomes a 4. And again, what I'm going to do is double this number times 2, which when you do that is negative 1084.4. So if you'll notice now, what I have is, as far as if I add this, let's look and see what I have. Notice I have 2 H2s that are on the right side of my arrows. 2 H2 is on the left side. So those cancel, which is good because I don't want H2 in my final equation. I have 4 HF, which will come down on the right side, which I want here, and I have an O2, which again will come down on the right side, which I want here. So the things I want are coming down on the right side. On the left side, I have 2 F2, which is going to come down, and I want that, and 2 H2O, which is going to come down, and that's perfect because I want that here. So now my equations add up. The things on the left I want on the left, the things on the right are on the right, and I have the correct numbers of them. So now I just simply add these. I'm going to take 2 times negative 542.2, and I get negative 1084.4. This is positive 571.86, and when I simply add those, I get negative 512.8. So that is my predicted delta H, or enthalpy change, for this reaction that I have not done. I was able to work with these two reactions and get them to add up to the one I want. So let me show you another example of one of these. Let's do maybe a different color for the pen. Let's do green this time. But notice what happens here. Again, I'm trying to get these to add up to this equation here at the end. So again, we're just going to look through here. Where do I want my phosphorus? Well, there is no phosphorus down here, so I'm going to want that to cancel. I also have phosphorus in this equation, so that lets me know I'm probably going to have to flip at least one of them so that I can get those to cancel. Cl2s, you'll notice they're in two different places. I do want some on the left, but I have a lot of them here. So we'll kind of keep going now, see if I get anything definitive. And here you go. Here's where I know what I need to do. PCl3, and here's my arrows. PCl3 is coming down on the left side of my reaction arrows. Here it's on my right. There is no PCl3 anywhere else, so that lets me know I am going to have to flip this first equation. So let me rewrite that as 2 PCl3 arrow 2P plus 3Cl2, and of course then this becomes positive. 640 point, and that's kilojoules. So now I have simply flipped that first equation. Now let's look at the second, and you'll notice PCl5 is on the right. I want PCl5 on the right, so I'm not going to change anything in this equation because I need this to be on the right side of my arrows. So now let's check our numbers. If you notice at the end I want 1 PCl3, but I have 2 right now. So what I'm going to end up doing is cutting this whole equation in half. So this is going to become just 2 divided by 2 is 1 PCl3. Same thing here, 1 phosphorus. And this is I'm dividing this by 2, so this becomes 3/2 Cl2. Well, again, whatever I do to the equation, I do to this number. So I'm going to divide this by 2, and of course that's going to become positive 320 kilojoules. Now let's look at our second equation. The 2 phosphorus I want on the left, I think, because I'm going to want these to cancel. Cl2s, again, I've got a lot of Cl2s, but again, if you come over here, notice I have 2 PCl5s in my original equation. In my final equation, when I add them, I only want 1 PCl5. So I'm going to cut this in half as well. So I'm going to, this divided by 2, of course, is just 1P. This is going to become 5/2, and then this is going to become 1. So again, I'm going to cut this in half as well. And so, of course, that's going to become negative 443. Now, if I go to add these guys, you'll notice I have a single phosphorus here and a single phosphorus here, which is good because I wanted those to cancel. I have 1 PCl3 on the left, and that's good because I wanted that to come down on the left side. And if you'll notice, I have 3/2 Cl2 and 5/2 Cl2. So I have 1.5 and 2.5. So 1.5 of these will cancel out 1.5 of these, leaving me a single Cl2 on the left side, which is perfect. That's what I want. And then I have 1 PCl5, and again, you'll notice that's here. So now my equations, the things on the left side, add up to what I want on the left side in my final equation. The things on the right side add up to what I want on the right side of my final equation. So everything adds up perfectly. So now that means if I add these, I can predict the delta H again for this unknown reaction. Negative 123 would be my answer in this particular case. Now again, just to give you a little background, why would you want to do this? Perhaps this reaction is undoable. Maybe it's really slow or very difficult to measure, so it allows me to predict whether it's endo or exothermic, how endo or exothermic, simply based on adding other reactions up. By the way, since these are both negative, they both are exothermic. They're both going to release energy as I go through the reaction. Now let's do a third example. Let me pick another color. I'll do this one in, let's do red for this one. And as I come down here, notice I have 3 reactions, but it's the same process. Notice I'm going to get the things, I'm going to go for the correct sides first. I'm going to say, okay, everything here is on the left side. I'm going to want that to come down on the left. Things here I'm going to want to come down on the right side. And so basically I just look at the correct things on the correct side first, then I do my numbers. So carbon, I seem to want carbons at the end. I don't have carbons anywhere else by themselves, so I'm not going to be able to flip that first equation. If I go to my second equation, H2 this is the only place I have H2. I want it on the left, so I'm not going to flip that one. When we get to this final equation, though, you'll notice I want this C2H2 to come down on the right side of my equation. So I am going to flip this one. So this is going to become 4CO2 plus 2H2O, arrow 2C2H2 plus 5O2. And again, since I have flipped that, this is going to become positive 2598.8. So I've simply flipped that equation and made it positive. Now I go and I check my numbers. Correct things, correct side first. Now I check my numbers. Notice at the end I want 2 C's. I only have 1, so I'm going to double this whole equation. I'm going to make this 2, and this 2. So of course I'm going to multiply this by 2. And when I do that, that becomes negative 787. This equation I seem to want 1H2 at the end, so that seems fine at the moment. And for this one, if you'll notice, I've got a couple of things here I have to deal with. The main one is that I have 2 C2H2s, but at the end I only want 1. So I'm going to cut this whole equation in half. So this is going to become a 2. This is simply going to become an H2O. This is simply going to become C2H2. And this is going to become 5 halves O2. So again, I'm going to divide this in half, and I'm going to get positive 1299.4. So now let's see, I flipped what I needed to, which is the third one. I got my numbers to seem to add up, so let me see what I have here. If you'll notice on this side, I have 2 O2s here, and I have a half an O2 here. And remember I said if they're on the same side, you add them. So I have 2.5 O2s. I have 5 halves O2. That's the same thing. 5 halves simplifies to 2.5, so they cancel. I have 2 CO2s on the right. I have 2 CO2s on the left. They cancel. I have an H2O on the left. I have an H2O on the right. They cancel. I have 2 C's coming down on the left side. That's what I want. I have an H2 comes down on the left. That's what I want. And then I have a single C2H2 that will come down on the right side of my arrows, and there we go. So now this adds up to what I want, so now I simply add my numbers. I take negative 787, add that to negative 286, and then I add that to positive 1299.4, and when I add all those numbers up, I get positive 226.4. So this would be an endothermic reaction as opposed to the exothermic that the prior two were. So again, basic idea, get the correct thing on the correct side. Get your numbers of things to be what you want at the end. As long as your equation adds up, you do the same thing to your delta H's, they'll add up, and that will give you a prediction on what the delta H for your unknown reaction will be.